Hello, honors kids. You guys got actually two reviews in your one review packet. Some of you probably noticed that. I'm going to do the second review part of the packet with you, and then you can use the first review to compare and see how you're doing. So I'm going to start with number one and just work my way through. So number one is pretty straightforward. The only thing you have to realize is that it's an odd root. That's why I have the 3 circled. And it's a negative under the root. If it's an odd root with a negative, it will not come out as an I. That's something you might want to have in your notes. So this one is going to come out as a negative. Now really those 5s that I have circled after I factor tree it down, the 3 5s, those are really all negative. So it's a negative 5 times a negative 5 times a negative 5. What's a negative times a negative times a negative? Obviously still a negative. So as I bring it out, I'm really bringing it out as 3 negative 5s. So that's why I have a negative 5 on the outside. And then I have how many x's? Well, I have 4, but I need a set of 3 or a triplet to bring one out. So I bring out 3 of those 4 x's. That's why I have an x on the outside. And then there are 8 y's under it, the root. I bring those out in triplets, or in groups of 3. So therefore I have one group of 3 and another group of 3. That's 6 of the y's, for y squared on the outside. But if I bring out the y squared on the outside as 2 triplets, there's still going to be 2 y's left under the root. So that's why I have a y squared both under the root and a y squared on the outside of the root. Hope that makes sense. All right, now we're going to go to number 2. This is number 2. First thing you want to do here is separate the roots. So you'll notice that I separated the roots, top and bottom. Then the bottom is pretty easy because it's a perfect square, so therefore it just comes out of the square root, which is nice because remember, you can't leave a square root in the denominator. But this one was a perfect square in the denominator, so it just came out. The top, I factor treat it down. 50 is obviously 2 and 25. 25 is 2 sets of 5, so I bring out a 5 because I have a pair of 5s. This y to the 6th, there are 3 pairs to make 6. In other words, you have 3 pairs of y's. So those all come out in pairs as y to the 3rd. Then I have a square root of 2 left over. That's my answer. Now going number 3 on the back side. Number 3 is one that you're going to have to use a conjugate. So the key here is, move this over just a little bit. You have a binomial in the denominator. The minute you see that, that's when you know you have to use a conjugate. So the conjugate is just with an opposite sign in the binomial. And I times that both to the top and the bottom. So timesing it to the bottom is pretty easy. What's the square root of x times square root of x? X. And then I just times, the inside and outside are going to cancel. That's why I'm multiplying by a conjugate. So I just have to times the last terms, or the x times the negative x. What is x times negative x? Positive times a negative is a negative x squared. Then I have to multiply out the top, so I'm just distributing that 3 through the top, which will give me 3x, or 3 square roots of x minus 3x all over x squared minus, or x minus x squared on the bottom. Number 4, as you see, this one is simply going to be one that you factor tree down. You'll notice I factor treed here the 4 and the 5. The 4 factor trees to a pair of 2's. I can bring a 2 out. As I bring it out, I got to multiply it by what's in front. So this pair of 2's is getting multiplied to that 2. That's how I got the 4x. The x squared came out as a pair. That's why it's an x on the outside. This 5 has to stay under the root. That's why it's a square root of 5. Same thing over here. I factor tree down the 45 to 9 and 5, 3 and 3. I have a pair of 3's, 3 times the 5 on the outside, make negative 15. The x was already outside, so it's negative 15x roots of 5. A lot of kids get to here and leave this as the answer on the test. Look and make sure that you don't have common terms or like terms. So because these are like terms, the x's are the same, The roots are the same. I can add those, and I end up with negative 11x roots of 5. Don't multiply these, add them. Okay, next one. This one just says, use the graph to solve the equation. Well, this is pretty easy because looking at the graph, I'm looking at the points it crosses the x-axis. And this one crosses the x-axis right at negative 3. So that's where that is. So that was easy. On the next one, we notice that there are no real roots. There are 2 imaginary roots. And the way we know that is the entire graph lies above the x-axis. So here's the x-axis down here, and this graph lies entirely above it. So we can put, hey, we have no real roots, 2 imaginary roots. Now I went ahead and solved for that using this equation. And I did that by the quadratic formula. That's really the only way to do it if you have imaginary roots, is to use the quadratic formula. So let me walk through the quadratic formula because we'll be using that a lot on these next problems. So I just did opposite of negative 12, which is 12, plus or minus the square root of 12 squared, which is 144, minus 4. That 4 is a constant in the formula, b squared minus 4ac. So that 4 is coming from the formula negative 4ac. So negative 4 times the a value, which was 3, times the c value, which was positive 14. So that makes 144 minus 4 times 3 times 14. Well, that's going to end up being negative 144 minus all those things multiplied is going to end up being negative 24. Now negative 24 factor trees down to 4 and 6. I bring out the negative as an I, and the 4 factor trees to a 2 and 2, therefore a 2i come out. The root of 6 stays under. Now I tried 12 plus or minus 2i roots of 6 all over 2a, which is 3 times 2. Uh-oh, I messed that up, didn't I? Okay, so this should have been a 2a, should have been a 6, and now I can reduce that, and I'm going to end up with 12 divided by 6 is 2. Well, no, I can't do that. I've got to see what will divide 2, 12, and 6 evenly. So I've got to put 2 goes into each of those, and I'm going to get 6 plus or minus, oh, sorry, you can't see that. Sorry, I'm going to get 6, let me show it like that, there we go, plus or minus, and then we have I roots of 6. Do not divide down what's under the root. What's under the root can't divide with something outside of the root, like this 6. So I'm now going to divide the 12, the 2, and the 6 all by 2, and I end up with a 3 in the denominator. That's going to be my answer. Let's move on to these. This says find the value of the discriminant and then determine how many roots there are. So all I really care about, looking back at this problem, is what was under the root. So notice how the 144 minus 4 times 3 times 14, let me do 4 times 3 times 14 so you know what that is. 4 times 3 times 14 is, that's 168. And so 144 minus 168 is going to be a negative value. That's all I really care about when I'm looking at the discriminant, because that tells me I'm going to have imaginary roots, or as you're looking at the graph, that it won't cross the x-axis. Therefore, when I get to number 7, the key here is make sure you set it equal to 0 before you start the quadratic formula. I see a lot of kids start the quadratic formula right off the bat, and they'll use a positive 7 for your b value. Really, that 7 has to be subtracted to the other side, and the b value is actually negative 7 to start. So make sure you set it equal to 0 before you start doing the quadratic formula. Now, really, I don't care about the first part of the quadratic formula. All I care about is the discriminant. So I'm taking negative 7 squared, which is 49, minus 4ac. 4 times 1 times 14. 4 times 14 is, I want to make sure I did that right, 56. So therefore I have 49 minus 56. Now the minute you see that this the second part of the discriminant, is bigger than is negative and bigger than the first part of the discriminant, you know it's going to be negative under the root. If it's negative under the root, you have two imaginary roots. Okay? Here's the next question. Again, I got everything equal to 0. So I really took the 4x squared over to here because I like a positive x squared. And I took the 9 over to the left side. So I ended up with 4x squared plus 12x plus 9. Again, 12 squared is 144 minus 4 times 4, that's this 4 in front, the a part, times c. And the c is the 9. So 4 times 4 times 9. Well, that's 144. So if I get 144 minus 144, I get 0. If 0 is the discriminant, which it is, then I only have one real rational root. It'll be whatever the opposite of b is. In this case, it would have been negative 12 over 2a over 8. So that'll reduce to, say, negative 3 halves. That would be my only real rational root, is negative 3 halves. It would hit there and then curve back up and only touch it at one point on the x-axis. Okay, number 9, again, I just get everything is already on the same side, so all I care about is the discriminant. Negative 1 squared is 1 minus 4ac. Well, that's easy because 4 times 2 times 3 is way bigger than 1. So therefore, it's completely negative. Once I know it's negative, I know there must be two imaginary real roots. Going down to number 10. Wait, here we go, number 10. Trying to find it, there we go. All right, so number 10. Solve the inequality by using the square root method. So here I just want to get the square part by itself. So I add 6 to both sides. How do I get rid of that fraction, 2/3 in front of the square? Well, I just multiply by the reciprocal. Because 2 is multiplying to it, 3 is dividing it. I do the opposite. Multiply by 3, divide by 2. That's going to get rid of that fraction in front. I've got to do the same thing to this side. 2 goes into 6 3 times. 3 times 3 is 9. Then I take the square root of both sides. And don't forget to take the plus or minus. There are actually two answers, positive 3 and negative 3. So my answer is x is equal to plus or minus 3. Okay. Number 11. Again, I want to get the root, the square part, which now is in parentheses, by itself. So I subtract the 1 and divide by the negative 4. That gives me positive 1/4. Then I take the square root of both sides. Well, the square root of 1/4, square root of 4 is 2. So square root of 1 is 1. So therefore I have x minus 3 equals, don't forget the plus or minus 1/2. Then I add 3 to both sides. 3 plus 1/2 is 3.5. 3 minus 1/2 is 2.5. Those are my answers. Looking at number 12. So going to number 12, I have, there we go, scoot that over just a little. So going to number 12, I have x squared minus 10x equals 13. The reason I'm doing it this way is I'm going to do completing the square. So in completing the square, you get the constant on one side, and then you get the quadratic and linear terms on the other. This is most easily done to use completing the square, and really the only time I use completing the square is when this linear term is even and there's no coefficient on the x squared. So notice the x squared is going to be a 1 in front of it for a coefficient, and the linear term is going to be even, like a negative 10. Now I'm going to complete the square. So I just take half of, this is why I like it being even, because I'm going to take half of it right off the bat, and half of an even number is still a integer value. So half of negative 10 is negative 5. Negative 5 squared, so you take half of it and then square it. So half of negative 10 is negative 5, and then you square it. That's how I got this 25 right here. Okay, so I have x squared minus 10x plus 25. If I add 25 to the left side of the equation, I've got to add 25 to the right side of the equation. So 25 plus 13 gave me 38. This side now is a completed perfect square trinomial. Therefore, I'm going to put one set of parentheses, x, square root of the first term, sine of the middle, square root of the last term, 5 squared. Then I just use the square root method, square root both sides, x minus 5 equals plus or minus the square root of 38. Again, don't forget the plus or minus. This one says round our answers to the nearest tenth. I've been doing everything as hundredths because half the test is in hundredths. When you do it on the actual test, everything will be round to hundredths or leave it in its root form. So if it asked me to leave it in its root form, that would be it. I would be done. Plus 5, as I add 5 to both sides, 5 plus or minus the square root of 38. But if I do it as my rounding to the nearest hundredth, those would be my two answers as I go. 5 plus the square root of 38, that's that one, and 5 minus the square root of 38, that's that one. Looking at 13. This one, it says solve by completing the square, but I'm not going to do that. I'm going to always take the easiest way to do it. Now, I always look to factor when there's no value in front of the square, or a coefficient of 1 in front of the square, a linear term that is odd, and a constant. If I can factor, it'll be easiest. If I can't factor, I'll end up using the quadratic formula anyway. So the first thing to do here is set it equal to 0 so that I can see if it'll factor, or if not, like I said, I'll use the quadratic formula. This one happens to factor. What multiplies to be 10 and subtracts to be 3? 5 and 2. So I do two sets of parentheses, x and x, 2 and 5. It's a difference, so the signs are different. The bigger one gets the sign in the middle. So the bigger one, the 5, will be positive, and the 2 will be negative. Set each of those factors equal to 0 and get the x by itself. I'll add 2 to both sides. I'll subtract 5 to both sides. Those are my answers. Looking at 14. Solve the equation using any method. And really, you can use any method on any of these all the way through. So again, the first thing I do is I look at that quadratic term. That's really my key term. If this has a 1 in front of it, which it does, and it's squared, I'm going to either use factoring or I'm going to use quadratic formula almost all the time. Now, if this linear term was even, I might do completing the square, but this one definitely isn't even, so I'm not going to use completing the square. So I'm going to get everything equal to 0. I subtract the 12. I add the 4x. 7 plus 4x makes 11x. Minus 12 equals 0. I say, hey, what multiplies to be 12? Subtracts to be 11. And obviously that's 12 and 1. They multiply to be 12 and subtract to be 11. So I put a 12 and a 1. It's a different, signs are different. Bigger one gets the sign of the middle. The other one gets the opposite sign. Again, set each of those equal to 0 and solve. So I'm going to subtract 12 to get the x by itself. I'm going to add 1 to get the x by itself. Those are my two answers. Next question. Here, I again look at that first term. This squared term is the giveaway as to what is going to be easiest to solve the equation. The minute I see a 2 in front of the t squared, I'm thinking, I'm going to do the quadratic formula. Now, are some of these factorable? Yes, but you'd have to use the box method to factor, and I'm not a big fan of the box method, so I'm just going to use the quadratic formula. In order to use the quadratic formula, again, you have to set the equation equal to 0. So I had to add 7 to both sides of the equation. Now, at this point, I'm going to simply use the quadratic formula. I'm not even going to mess with the box method. I probably could on this one, but I'm not going to worry about it. And I'll show you how I know I could use the box method on this one. So here I'm going to have just quadratic formula opposite of b. So instead of positive 9, it's minus 9. Plus or minus the square root of b squared, that's 81, 9 squared. Minus 4 times a times c. So negative 4ac. The 4 is a constant that you use every time you do the quadratic formula. The a and the c come out of the quadratic equation. Now I'm going to multiply those together. Negative 4 times 2 times 7 is negative 56. 81 minus 56. Now 81 minus 56 is 25. And now when I get 25, and that's a perfect square, I know that that would have factored. So really, I could have factored this one using the box method, but it's not worth it anyway. I'm already there now with the quadratic formula. So I have negative 9 plus 5, negative 9 plus 5 is, negative 4 over 4, which is negative 1. Negative 9 minus 5 is going to be negative 14 over 4, which is equal to negative 3.5. Those are my answers. Flipping it over, we're doing number 16 now. Wait, I gotta go this way. Sorry. And get it right there. All right, again, still doing the square root method. How do I know to do the square root method? There is no linear x-valued term. In other words, you'll notice there's an x squared term, which is your quadratic term, and there's a constant term, which is the 80, with no x with it. There is no linear term. There is no x to the first power in this equation. That tells me that I want to do just the square root method. So I'm going to divide both sides by 5. That gives me the 16. And then I'm going to square root both sides. X is equal to plus or minus 4. Again, don't forget the plus or minus. There's actually two answers there, positive 4 and negative 4. Next question. Again, I notice, hey, I have a 9a squared. The minute I see a number in front of coefficient that isn't 1 in front of that a squared, and I see a linear term, remember on the previous one, we didn't have a linear term, I say I'm going to have to use the quadratic formula. So I bring everything over to the left because I want to keep that quadratic term positive. It makes it way easier to do, and it doesn't mess up my signs as much. So I'm going to have positive 9a squared minus the 7a as I bring it over, and minus the 4 as I bring it over, and set it equal to 0. I can't stress enough how important it is that you set the equations equal to 0 before you set up the quadratic formula. At this point, we just simply set up our quadratic formula. Opposite of b, plus or minus the square root of b squared, minus 4ac. Make sure you keep that negative with the c value. So now I have a negative times a negative is going to be a positive. 4 times 9 times 4 is 144, plus 49. That gives me 193, squared in 193. This one asks for decimal values, so that's going to be 13.89. And then I'm going to take 7 plus 13.89 and divide by 18. How come I'm dividing by 18? Well, 18 is 2a. Very often, I have kids always put a 2 down here, and they forget that it's not divided by 2, but divided by 2a. So you got to take that 9 times 2, which gives me the 18. That gives me 1.16. And if I do 7 minus 13.89 divided by 18, that'll give me negative 0.38. That decimal's kind of weird there, but it's 0.38. Okay, now on the next one, it says, now this one, these two questions I'm going to kind of look at this at the same time, 18 and 19. The key here is the top one is an add or subtract problem. You can see the plus or minus between the two complex numbers. The second one is a multiplication problem. There is no plus or minus between the parentheses of the complex numbers. So the first one is just simply an add or subtract problem. I simply distribute the negative through. Negative times a positive is a negative 4. Negative times a negative is a positive 5i. And then I add my like terms. Negative 4 plus 1 is negative 3. And 5i minus I is plus 4i, and I'm done. Super easy. When I multiply it, these are not conjugates, so the i's will not add to 0 as I multiply it out. And that's important to pay attention to, because I have a lot of kids who just simply multiply the first terms, they multiply the last terms and think they're good. That's true if you have conjugates, but these are not conjugates, so I have to multiply it all the way out. So I take negative 4 times 5 is negative 20. Negative 4 times negative I is a negative times a negative is a positive 4i. 5i times 5 is going to give me plus 25i. 5i times negative I is going to give me a negative, oops, I messed this one up, sorry, negative 5i squared, and that's going to give me a negative 5 times negative 1. Well, where'd the negative 1 come from? Well, I squared is negative 1. Remember our I chart? The I squared, the I cubed, and the I to the fourth. I squared is negative 1. So therefore I have negative 5 times negative 1 should be a positive 5. That's going to change that answer because I messed that one up. Negative 20 plus 5 is negative 15 plus 29i, because I have the 4i and the 25i, which made the 29i. Okay, let's do 20. This is, there's quite a few of these. You have a basketball or something that's going up through the air, and it's going to come down because of gravity. So remember, this negative 16 represents the gravity. Remember, this is the velocity that you're pushing the ball with. So this is like 22 feet per second. This is negative 16 feet per second squared. And this basketball player is how tall? 6 feet tall. So the ball is being launched. Well, he may not be 6 feet tall, but the ball is being launched from a 6 feet tall angle. So that's where we push the ball up in the air. So that's what those coefficients each represent. H of t means the height at any given second of time. So that's what h of t. H really represents, this part represents the height. And in this case, it asks us, hey, when will the height, between which values will the height be bigger than 8? In other words, I'm pushing the ball up in the air, and it's going to cross, a horizontal line of 8 feet twice, once on the way up and once on the way down. Let me draw that. So like if we have, here's 8 feet high, right? Here's my 6 foot person. I'm going to draw a real pretty picture because I'm a really good artist here. So they're pushing that ball up from a height of 6 feet. So that height is 6 feet. And they're pushing that ball up in the air. It's going to cross the 8 foot. The gravity is going to bring it back down. And it's going to cross this again at 8 feet. Okay, so it's asking, at what 2 points will it be there? Will it be crossing that 8 foot horizontal line? So I can solve that really easy because the height, remember I told you when we did the equation, this represents the height. I just replace it with 8. So my equation now is 8, that's the height I want it to be, equals negative 16t squared plus 22t plus 6. Again, I want to set that equal to 0 before I do anything else, because I'm going to use probably quadratic formula to do this. But I'm going to subtract 8 from both sides. That gives me negative 16t squared plus 22t minus 2 equals 0. I divide everything by negative 2 just to make that positive. It makes it easier to deal with when doing the quadratic formula. And then and dividing 0 by negative 2 doesn't change it. It's still 0. So every one of these get divided by a negative 2. Negative divided by a negative is a positive divided by a negative is a negative, and a negative divided by a negative is a positive. And each one of them I just cut in half. At that point, I use the quadratic formula. Opposite of b, so this is my b value. Opposite is 11, plus or minus the square root of 11 squared, that's 121, minus 4 times a, that's the 8, times c, that's the 1. Then I multiply those out. That's going to be 121 minus 32. I took the square root of that. 121 minus 32 is, let me do that off here to the side, 121 minus 32, that's 89. So the square root of 89 is the 9.43. So there's 2 places it happens, 11 plus 9.43, I'll do that over here on this side. 11 plus 9.43 divided by 16, that's at 1.28 seconds, that's on the way down. On the way up, it's at 11 minus 9.43 divided by 16. That's just 0.1 second. That's almost immediately after it leaves his hand. It's going to cross the 8 foot mark It's going to arc up in the air and then come back down after 1.28 seconds at the 8-foot mark also. So my answer can be written this way. T has to be between or greater than -1 or greater than 0.1 and less than 1.28 for the ball to be traveling in that interval above the line 8. In other words, you're really shading this area. So it's between those two values where it will be above the 8-foot line. All right, let's do 21. 21 just says solve the system using any method. We've done a lot of these already, so I'm not going to really go through the whole thing. I'll show it and you can rewind it if you want to kind of work your way through it. But I am going to use the square root method, or sorry, solve this. Oh, this is a system. Sorry, let me go through this. So solving the system using any method. So the first thing I did is I squared out the parenthesis. So that gave me this x squared. It was really this. It was x squared minus 2x plus 1. First term squared, first term times second term times 2, last term squared. Then I took the 1 plus the 3, added them together, and got a plus 4. But I times the entire equation by a negative because I'm going to use the elimination method. So I have negative y, negative x squared, positive, negative times a negative, positive 2x, and then a positive times a negative, negative 4. Then I add those two. I'm going to add this equation with a negative y, that's key, to this top equation, solve for y. So I got the y by itself, I just added the 2x squared to the other side. So now I have y equals 2x squared plus 1. Now I'm going to add these two together, thus eliminating, and that's why we call this elimination, the y's and having it equal to 0. So 2x squared minus x squared gave me x squared. Then I don't have any linear term to add to the 2x, so it just becomes plus 2x. And then I have 1 minus 4. 1 minus 4 gives me the negative 3. Well, that factor is simple enough. Solve for x. When I get those values of x, this is the key. A lot of kids stop right here. Do not stop. Substitute these values back into one of the two equations. I subbed them in right there. So I just took negative 3 squared, which would be 9, times 2 is 18, plus 1 is 19. So my first answer was the negative 3x, and then the y value, when I substitute that in, is going to be 19. Next I sub in the 1. 1 squared is 1, times 2 is 2, plus 1 is 3. Therefore I get the 0.13. Those are my answers. Going to 22. So on 22, again, I'm going to use elimination. Now, on this one, I didn't even change the format. I just noticed that both y's were negative, and I'm going to multiply the top one, which doesn't have a square, by a negative all the way through. So I change every sign. So the plus 4x became a negative 4x, the negative y became a plus y, and the 4 became a negative 4. Then I just simply added them because they were already in standard form, so it doesn't really matter at this point anyway. So I just add them, x squared minus 4x minus 5. Again, set it equal to 0, solve, and this is the problem. And most people are going to read that too quickly and say, oh, what times to be 5 and adds to be 4? Oh, it's 5 and 1. No, 5 and 1 add to be 6. So if that middle term would have been a 6, I would have been okay. Or if this would have been a minus sign on the end, I would have been okay. But because it's a plus 5, this doesn't factor, which means you have to use quadratic formula. So I use the quadratic formula, 4 plus or minus the square root of 4 squared, which is 16, minus 4ac. So minus 4 times 1 times 5. 4 times 1 times 5 is negative 20. 16 minus 20 is negative 4. That tells you it's an imaginary root. It tells you that these do not cross. Okay? So solving this system is actually no solution. Now I went ahead and solved it out to the side, but that's really all you need is no solution there. Okay, going to 23. It says graph the inequality of the systems. Well, that's actually fairly easy. You can do that on your graphing calculator. All you got to do is solve for y. So I get the y by itself. I actually added y to the other side and subtracted the 5. You must read from the y though. So reading from the y is less than the graph of the parabola. Now this one I can graph without a graphing calculator really easy because all it is dropping down 5. Notice that they're counting by 2's on the graph here. And so I'm going down 1, 2, 3, 4, 5. So that's really, it looks like -4.5, but it's really -5 because we're counting by 2's. So I'm starting at -5, and then my a value is 3, so I'm just using the parent graph. I'm going over 1, normally up 1, but now I'm going over 1 up 3 times 1. Normally I would go over 2 and up 4. 4 times 3 is 12, so I went up 12. And then I just graph it, shade the outside or below it. And the reason I'm shading below it is because y is less than the graph. Next one. We're going to, we're going to graph this sucker. And it is kind of beastly because of the y squared. So I have to solve for y. So I actually subtract the x. You'll see that right here. And then I have to take the square root of both sides, which is plus or minus the square root of this. So I have a plus or minus the square root of -x plus 3. I can still punch that into my calculator and graph it, okay? So I'm going to actually show you that I put into my graphing calculator. Hopefully I'll show you that. If I can get this to maneuver correctly. I'm kind of falling here. Let's see if I can get that. Oh, there we go. Okay, so as I punch it into my calculator on this, I want to do the square root, and it'll start a parenthesis with you under it. Make sure you do the square root of negative, and then I hit my xt theta key, plus 3, and then I close the parenthesis. Then I go down. Put a negative sign in front of the square root. Do not hit your minus sign on your calculator. Your negative sign is right underneath the 3 on your calculator. Make sure you use a negative sign there and not a minus sign. That's true also when you get inside this square root. That needs to be a negative sign right underneath the 3. Do not use a minus sign there or it'll say syntax error and it won't graph it. I get all done with that. I put in the line, that's the 3x plus 1, and then I graph it. Okay, so that's what my graph looks like. Now I can hit calculate, and then I'm going to calculate the intersection, and I can find where these cross. So there's my first curve, yes. I don't want to use this second curve. The second curve is the negative underneath it. So I want to actually hit my down cursor key and get closer to that where they cross, and then say, okay, that's the second curve. And do you want me to take a guess? I'm like, yeah, take a guess. And it tells me that the intersection is at 0.22 and 1.667, or 1 2/3. So I graph this out on my graph, and you'll notice that I put that in there as 0.22 and 1 2/3. That's where those crossed. I found the other points similarly, just using calculate the intersection. Make sure you use the second equation and the third equation, or your down cursor, to do that. And that ended up at -1, 2. Now, how did I know this is the area to be shaded? Let's go back over here, and this is a little bit tricky to think about what's going on in this equation right here. So as I do the square root of both sides, plus or minus, think of values that I could plug in here. Well, if I plug in 0, which obviously is going to be wherever these two curves meet, if I plug in 0 to this, it's going to give me the square root of 3. So 0 square root of 3. Well, square root of 3 is obviously less than 2. It's going to be in this shaded area, this area underneath here. And so notice that will happen if I plug in -1 also. I end up with -1. If I put in negative times a negative, that will be a +1. 1 1 plus 3 is 4. The square root of 4 is 2. Notice 2 is inside this little shaded area. Okay, so this is the area under the curve. Now, by the way, the negative is just saying, hey, it would also be negative square root of 2. So that's barely inside that curve also. So those are the values of this curve that I'm finding. And it has to be, y has to be greater than this curve, meaning that it's really got to be inside of that curve. And I'll show you why outside will never work when you have this type of thing. Let's assume that I put in, say, a 4 for x. That's going to give you an imaginary number. That's anything on this outside. See how 4 is on the outside of this curve? Notice that if I put in a 4 there, 4 plus, or negative 4 plus 3, that's going to be a negative 1. That's an imaginary number. So anything out here is going to give you an imaginary value. That's why you have to shade under those, in between those, I should say. And then obviously the linear is less than the line. So that's my shaded area. That one's a little bit complicated. Next one is 25. 25 is this pool one. It tells us it's 5 by 8. It tells us that we're going to do another length of x for the fencing, that we're going to have this walking path around it, and we're going to put fencing around the pool. So this walking path is represented by x's, but we have to have double that walking path where the lifeguard's going to sit on this side. So I just say, okay, that one has to be twice x. Now think about this. What's the whole length then? Well, I have x plus the 8 plus the other x. X plus 8 plus x. This width is going to be the x plus the 5 plus the 2x. That's the width. Thus giving us this equation, 2x plus 8 is equal to, or times 3x plus 5 will equal the area of x. Tells us the area of the x needs to be 442 square feet, so I sub that in for the area of x. I multiply it out. I then add my like terms. I then subtract the 442. I then divide everything by 2 because I see all these are even. It just makes it smaller and easier to work with. You could stop right here and start doing quadratic formula if you want, but I like making things smaller, making them easier to deal with. So then I divide everything by 2. That's what I get. I do the quadratic formula. I'm not going to go through that because we've gone through it so many times. And I end up with negative 17 plus or minus, and then I'm going to end up with the square root of that divided by 6. I think that's going to end up being a 52 in there, but I can't remember. Anyways, oh no, it's this 270.01, which actually comes out as about 52. And then I do plus or minus with that. I actually did the actual decimals, and I ended up with negative 17 plus that divided by 6. That's going to be the 5.8 whatever. You don't care about the minus because you can't go in a negative distance. So I don't care about the negative 17 minus the 52 point what divided by 6. But I do care about the positive. So that's my x distance. The side that the guy is going to sit on is going to be 11.67 feet. And then the other 3 sides are going to be 5.83 feet. So remember that how much fencing should you buy? To do that, you're just simply doing the perimeter. The perimeter is 2 widths plus 2 lengths. So the perimeter, if you look back at your picture, is all the way around here. So I'm doing x plus 5 plus 2x, and then x plus 5 plus 2x again. And then I'm doing x plus 8 plus x, and then I'm doing x plus 8 plus x again. So that's how come I have 2 lengths and 2 widths as I do this one. And I end up with 2 times that, that's all the math, and then 2 times that, which is all the math. Add those together, and I need 84.3 feet of fencing. Always better to have a little more, so I say, hey, it's better to buy 85 feet of fencing to be safe. 26, not 28. So 26 says, hey, you're going to be vacationing, you're going to go bungee jumping off a cliff, Doesn't that sound fun until the bungee cord breaks, and then, well, good luck with that. Your height as a function of time is modeled by this function. Again, we talked about this a little bit. This negative 16 is the gravity of 16 feet per second pushing down on you. You're going to jump off the cliff upwards as you jump up and away from the cliff at 16 feet per second, which is pretty dang good, actually. And then you're going to be 370 feet above the water to start with. So that's your initial height. Okay, so that's what's happening. It then says, find the following things. How long did it take you to reach your maximum height? And what is the highest point you reached? Well, really all you're looking for then is the vertex point. A couple of ways you can do this. You can simply graph this on your graphing calculator, calculate the maximum value, and you'll get it. I did it the old school way of solving it by finding the vertex. So in order to find the vertex, I do negative b over 2a, which is going to be negative 16 over 2 times negative 16. A negative over negative will give you a positive half. And so 1/2, meaning 1/2 seconds after you jump, you're going to reach your maximum height and you're going to start coming down. So I plug in a half, and again, a half squared is a fourth. The 4 goes into the 16, negative 4. A half of 16 is 8, plus 370. I'm going to end up reaching a maximum height of 374 feet. In other words, my vertex point is in half a second. That's how long it will take to reach the maximum height. I will reach a maximum height of 374 feet. That's the y value of the vertex point. So that answers questions A and B. Now question C is a little bit different. It says, when will you hit the water? Okay, and it's basically when you've passed out, because why are you jumping off a cliff? You're not very smart, and you're going to get a little nervous and scared, and you're probably just going to pass out. Now, if you don't pass out, this is how long it's going to take you to hit the water. And the way you do that is you set it equal to 0, which isn't very hard. And then I divided everything by negative 16 because it said I wanted it as a decimal anyway. And I can do quadratic formula with a decimal pretty easy. So I divided everything by negative 16, making all the numbers pretty small. So when I did my quadratic formula, you can see my quadratic formula becomes just small numbers. Negative 1, that's the opposite of b, plus or minus the square root of 1, minus 4 times 1 times negative 23.125. And make sure you do a negative times a negative, which will make that a positive. So I end up with 92.5 for that value, which is a total of 93.5. I'm dividing by 2 because it's 2 times 1. That's why I like dividing by that negative 16. So now I have negative 1 plus or minus the square root of 93.5, which is 9.67, all over 2. Negative 1 plus 9.67 divided by 2 is the only one I care about. Again, you can't go back in time, though after you jump off that cliff, you probably wish you could, unless the bungee cord pulls you back up onto the cliff, at which point it bangs your head against the cliff and you die. Just a thought. Okay, so I only really care about the positive time there. So I'm going to go negative 1 plus 9.67 divided by 2, which gives you 4.34 seconds is when you're going to hit the water. For 4.34 seconds, you'll be alive and excited, but probably at about after about 2 of those seconds, you're wondering why you did that, and you'll pass out, and you're going to miss out on the other 1.34 seconds. All right, or 2.34 seconds, my bad. Oh, that's it. Okay, have fun. Talk to you later. Bye.